this coffee 9 ringgit? I remember back then it's just around 5. Inflation is eating everyone pocket right now. But why is this happening? Is it because Malaysia's economy is growing too fast? That's GDP. Is it because Malaysian market shift and more people are looking for work? That's unemployment. Or is it because Malaysia's budget playing a major role? That's government spending. Good day everyone, I'm Karina. We are from Group 2D. Today, we are going to talk about factors affecting inflation in Malaysia. There will be 5 members who will be joining this sharing session with me.
What is inflation? Inflation is a persistent macroeconomic issue that may affect the price stability, purchasing power, and also overall economic performances. Thus, understanding what drives inflation is essential for policymakers when designing those effective economic policies. This study examines how 3 macroeconomic variables such as unemployment, GDP, and government spending affect inflation in Malaysia. Although these variables are commonly recognized as important determinants of inflation, their impact may vary across different economic conditions. Therefore, this study applies a multiple regression model to empirically analyze how unemployment, GDP, and government spending influence inflation in Malaysia. The objectives of this study are, first, to develop an econometric model that identifies key determinants of inflation. Second, to assess whether the estimated coefficients are consistent with economic theory. Third, to test the statistical significance of the explanatory variables. And finally, to apply diagnostic tests to evaluate the reliability of the model. The study uses annual data from 1995 to 2024, covering 30 years. This period provides a sufficient sample size for regression analysis, captures important changes in Malaysia's macroeconomic environment, ensures data consistency, and strengthens the reliability of statistical inference. Next, let me explain about the economic theory. First is about the unemployment rate. Unemployment refers to the proportion of the labor force that is willing and able to work but is unable to find a job. Based on the Phillips curve, there exists a short-run inverse relationship between inflation and unemployment. Rising inflation often reflects stronger aggregate demand in the economy. When aggregate demand increases, firms expand their production to meet higher demand, which raises the demand for labor and leads to a reduction in unemployment. Secondly, is about the gross domestic product, which is GDP, that measures the total value of goods and services produced in an economy and is commonly used as an indicator of overall economic activity. According to demand pool inflation theory, higher economic growth increases aggregate demand. When GDP rises, household income and businesses' investments tend to increase, leading to higher consumption and spending. As aggregate demand expands beyond productive capacity, firms respond by raising the prices, resulting in higher inflation. Additionally, Okun's law explains the link between GDP and unemployment. Okun's law states that an increase in the real GDP is associated with a decrease in the unemployment rate. As economic output expands, firms require more labor to meet higher production level, leading to job creation and lower unemployment rate. Lower unemployment rate increases the household's income and spending behavior, which further stimulates consumption and aggregate demand. This reinforces the demand pool pressures in the economy and can lead to higher inflation when the economy operates near or above its potential output. Lastly, is about the government spending. Government spending refers to public expenditure by the government on goods and services including infrastructure, public services, and social programs. According to Keynesian economic theory, an increase in government spending raises the aggregate demand in the economy. Higher aggregate demand stimulates economic activity and increase their pressure on productive capacity. When aggregate demand exceeds supply, firms respond by increasing the prices, leading to a higher inflation.
Today, we are putting on our economics hat and break down a regression model that explains inflation, which is the INFL. So, here is our general economics model. It looks like math, but it's actually a story about how the world works. Then we run the number using the OLS, which is the ordinary least square. And here is the estimated regression model. You can look over the unemployment rate. For every 1% increase in unemployment, inflation actually dropped about 0.68%. So it is tracked with the Phillips curve. And for the GDP, a rise in GDP has a tiny positive push, which is around 0.03 on inflation. And for the last one is the government spending. Interestingly, in this specific data, government spending show a negative relationship, which is negative 0.41. So later on we will explain more about it. But wait, you'll see the data yield at the end of the model. That's the arrow term. Since our data cover the COVID-19 era, this term is doing heavy lifting. It's captured the effect of omitting variables like the supply chain disruption, the exchange rate swings, and also the black swan event like the unexpected lockdown or global oil price shock. So we are using a linear functional form for this regression model, which is essentially the most direct way to measure how variable interacts. By using a linear model, we get a direct look to the marginal effect. This means that each coefficient tells us exactly how much inflation moves with one specific variable, like the unemployment rate. For every change in by 1%, when we hold the GDP and government spending perfectly still, it provides a direct, unit-for-unit explanation for the relationship.
Hi everyone, I'm Tanwei. So I'm going to discuss estimation and analysis. So for this section, we analyze the determinants of inflation in Malaysia from 1995 to 2024 using OLS regression. So in Model 1, inflation is explained by unemployment, GDP growth, and government spending. The estimated equation is inflation equals to 10.4547 minus 0.6794 times unemployment plus 0.0285 times GDP minus 0.4910 times government spending with the error term. So the result shows that the unemployment has a significant negative relationship with inflation, supporting the Phillips curve, while GDP growth has a positive but statistically insignificant effect, indicating that economic growth alone was not a major driver of inflation. In contrast, government spending has a significant negative impact on inflation, reflecting that Malaysia's fiscal structure, where subsidies, price controls, and supply-side spending help stabilize the price. Next, we then introduce a COVID dummy variable in Model 2 to capture the structural disruption during 2020 and 2021. So the dummy takes a value of 1 for those years and 0 otherwise. After including the dummy, the R-square increased slightly, suggesting that a marginal improvement in explanatory power. However, the adjusted R-square declines, indicating that the added variable does not meaningfully improve the model once complexity is considered. The COVID coefficient itself is negative but statistically insignificant, suggesting that the pandemic didn't have a strong independent effect on inflation. Instead, its impact appears to be indirect, operating through higher unemployment and slower GDP growth. The Table 1 presents a comparison of the regression results for both models. Standard errors, t-statistic, and p-values are reported alongside the coefficients to assess individual variable significance. Comparing both models, Model 1 shows stronger overall significance, better explanatory power, and greater theoretical consistency. Therefore, Model 1 is selected as the preferred model for explaining inflation dynamics in Malaysia. In this section, we compare our regression results with economic theory. Unemployment shows a negative relationship with inflation, which match with the Phillips curve theory, while GDP growth has a positive but insignificant effect on inflation, aligning with demand pull inflation theory, so its impact is weak. However, government spending shows a negative relationship with inflation, which differs from traditional Keynesian theory. This can be explained by Malaysia's use of subsidies, price controls, and supply-side spending, which helps stabilize the price. In the final section, Model 1 is selected as the preferred model because it has a higher adjusted R-square, stronger overall significance, and more stable coefficients. Including the COVID dummy in Model 2 increases complexity but doesn't improve explanatory power. Therefore, Model 1 is more robust and suitable for explaining inflation in Malaysia.
Hi, I'm Wenjing. Based on the model selection, Model 1 was chosen as the preferred model. In this section, we conduct a series of diagnostic tests to verify whether Model 1 satisfies the classical linear regression model assumptions. These tests ensure that our coefficient estimates are unbiased, efficient, and reliable for inference. The first test that we conduct is variance inflation factor, which is VIF. The null hypothesis is there is no multi-collinearity among the independent variables. The alternative hypothesis is there is multi-collinearity among the independent variables. We use the variance inflation factor to detect multi-collinearity. The centered PIF values are unemployment rate 1.298, GDP growth 1.233, government spending 1.06. Since all VIF values are far below the critical value of 10, we fail to reject the null hypothesis. This indicates that the independent variables are not highly correlated with each other. Therefore, multi-collinearity is not a problem, and each coefficient can be interpreted independently. The second is Jack-Barra test. The null hypothesis is the residuals are normally distributed, and the alternative hypothesis is the residuals are not normally distributed. The Jack-Barra statistic is 0.189 with a p-value of 0.9096. Since the p-value is greater than the 5% significance level, we fail to reject the null hypothesis. This confirms that the residuals are normally distributed, which is important for valid hypothesis testing, especially t-test and f-test. For now is the Durbin-Watson test. There is no first-order serial correlation for the null hypothesis, and an alternative hypothesis is there is first-order serial correlation. The Durbin-Watson statistic is 2.025, which is very close to 2. This suggests we fail to reject the null hypothesis of no autocorrelation. And the next is Burst-Godfrey LM test. The null hypothesis is there is no serial correlation, and the alternative hypothesis is there is serial correlation. The OBS R-squared p-value is 0.3566, which is greater than 0.05. Thus, we fail to reject the null hypothesis. Both tests confirm that the residuals are independent over time. Therefore, the model does not suffer from autocorrelation, and no corrective measures such as Cochrane-Orchard are required. And for now is Burst-Pagan-Godfrey test. The null hypothesis is the residuals are homoscedastic, and the alternative hypothesis is the residuals are heteroscedastic. The OBS R-squared p-value is 0.0745. Since this value is greater than 0.05, we fail to reject the null hypothesis. And the next one is White test. The null hypothesis is the residuals are homoscedastic, and the alternative hypothesis is the residuals are heteroscedastic. The White test p-value is 0.1814, which is well above 0.05. Therefore, we again fail to reject the null hypothesis. These results confirm that the variance of the error term is constant. Hence, the standard errors are reliable and do not require robust correction. And the last diagnostic test is Ramsey reset test. The null hypothesis is the model is correctly specified, and the alternative hypothesis is the model is incorrectly specified. The Ramsey reset test yields an f-statistic p-value of 0.0645. Since the p-value is greater than 0.05, we fail to reject the null hypothesis. This indicates that the linear functional form is appropriate and there is no evidence of omitted variable bias. Model 1 passes all diagnostic tests. There is no evidence of multi-collinearity, non-normality, autocorrelation, heteroscedasticity, or model misspecification. Therefore, the OLS estimates satisfy the classical linear regression model assumptions and can be considered best linear unbiased estimators.
Now that we have analyzed the data, what does this actually mean for Malaysia? Based on our findings, we have 3 key recommendations. First, since unemployment can push inflation up, we recommend that the government should focus on quality job creation that matches the skills of the workforce to prevent the economy from overheating. Second, we should focus on productivity-based growth. Instead of just spending more, Malaysia should invest in technology and automation. This allows the economy to grow and produce more without necessarily forcing prices to rise. Third, we recommend that the government continues to use targeted spending like infrastructure or food subsidies, which helps reduce production costs for businesses and keep prices stable for the people. To conclude, our study of the last 30 years shows that while unemployment and GDP follow traditional economic theories, Malaysia's government spending plays a unique role in stabilizing prices. Even with major shocks like COVID-19, our diagnostic tests prove that our model is reliable and statistically sound. We hope this finding help explain the complex relationship between our economy and the cost of living.
That's all from us. Thank you for watching us.